Look up at the night sky. Among the countless stars, one glows with a steady reddish hue. Mars, the fourth planet from our sun. For millennia, humans have woven Mars into myth and legend, its rusty color inspiring tales of war and wonder. The Romans named it after their god of war, seeing blood in its hue. When telescopes revealed mysterious lines on its surface, imagination soared. Could there be life? Though those canals were illusions, our fascination only deepened. Mars became a symbol of the unknown, a new frontier. The dream of reaching Mars is rooted in our nature as explorers, always seeking the next horizon. Mars challenges us, testing our ingenuity, resilience, and courage. It stands as a cosmic mirror, reflecting our hopes and ambitions. To set foot on Mars would be more than a scientific feat. It would mark humanity's leap to becoming a multi-planet species. The dream is alive, and our generation may be the one to make it real. The journey to Mars is a monumental voyage across the vast ocean of space. It starts on Earth with a towering rocket, launching astronauts beyond gravity's grip. Timing is everything. Launch windows open only every 26 months, requiring precise calculations. The spacecraft follows a Hohmann transfer orbit, a sweeping arc that takes 7 to 9 months. Life aboard is cramped and demanding. Astronauts maintain systems, conduct experiments, and exercise to stay healthy. They are a tiny world adrift, carrying humanity's hopes. As Mars nears, the most dangerous phase begins. The capsule must slow dramatically to enter orbit. The infamous 7 minutes of terror sees the lander plunge through the thin Martian atmosphere, heat shield blazing. Parachutes and retro-rockets slow the descent. Finally, the lander touches down on alien soil. The long voyage ends. Humanity has arrived. The first moments on Mars blend awe with caution. Astronauts check their systems, then step onto the red dust, humanity's first footprint on another world. Survival depends on building a safe base, likely an inflatable habitat brought from Earth. This high-tech shelter is pressurized and provides breathable air, powered by solar panels and backed by robust life support systems. The habitat is more than shelter. It's a lab, a communications hub, a medical bay, and a garage for rovers. Every system must have backups. Help is millions of miles away. The first pioneers are busy, setting up equipment, testing systems, and beginning scientific exploration. They collect samples, deploy weather stations, and map the terrain. Outings in pressurized rovers expand their reach. These astronauts are not just visitors. They are founders of a new human outpost. Their work lays the foundation for future settlers. A patch of alien dust becomes the seed of a new civilization. The Martian settlement begins. As the colony grows, permanent structures are needed to shield against radiation and dust. The best solution: build underground or use Martian soil for protection. 3D printing with local regolith allows robots to construct domes and tunnels, making use of what Mars provides. Living quarters may be subterranean, connected by tunnels lit with artificial sunlight. Above ground, transparent domes house greenhouses, town squares where colonists gather and glimpse the alien sky. Habitat design must support psychological well-being, with open spaces, virtual windows, and communal areas. The goal, not just survival, but a true home. Martian architecture will blend safety, comfort, and community. A new society will flourish beneath the red dust. Feeding a Martian colony means growing food on site. Resupply from Earth is not an option. Greenhouses, housed in domes or underground, become the heart of the settlement. Martian soil is toxic, so it must be processed and enriched with nutrients and recycled waste. Early crops, lettuce, radishes, potatoes, are grown hydroponically, with every drop of water recycled. Plants use astronauts' exhaled CO2 and return oxygen, creating a closed-loop system. LED lights mimic sunlight, ensuring healthy growth. Fresh food is vital for both nutrition and morale. Gardening offers comfort and a connection to earth. The greenhouse is more than a farm. It's an oasis and a symbol of life. Human ingenuity turns barren soil into sustenance. Water and air are essential, but Mars offers neither in ready form. Water ice lies beneath the surface and at the poles. Colonists must mine and melt it. Heated drills or ovens extract water from ice-rich soil, which is then purified. Electrolysis splits water into hydrogen and oxygen. The latter fills habitats with breathable air. Hydrogen can fuel rockets or power systems. Oxygen can also be made from the CO2-rich Martian air, as NASA's MOXIE experiment has shown. Scaling up these technologies will provide air for breathing and fuel for exploration. Mastering resource extraction is key to survival. Settlers must become expert prospectors and chemists. By harnessing Mars's resources, a self-sustaining colony becomes possible. The hostile planet becomes a source of life. Mars presents dangers unlike any on Earth. Its gravity is just 38% of Earth's, causing muscle and bone loss. Astronauts must exercise daily to stay healthy. Colossal dust storms can last weeks, coating solar panels and clogging machinery. Fine, abrasive dust threatens equipment and habitats, demanding constant cleaning and maintenance. The greatest threat is radiation. Mars lacks a magnetic field and thick atmosphere, exposing colonists to cosmic rays. Habitats must be buried or shielded with Martian soil. Spacesuits need top-tier protection. Life is governed by strict safety protocols and technological dependence. Colonists must be resilient and cooperative. Any mistake could be fatal. The Martian environment shapes daily life and culture. Survival on Mars is a triumph of adaptation and teamwork. The ultimate dream is to transform Mars into a second Earth, a process called terraforming. The first step: thicken the atmosphere and warm the planet, perhaps by releasing greenhouse gases or focusing sunlight with orbital mirrors. As Mars warms, ice melts, releasing more CO2 and water, creating rivers and shallow seas. The sky would shift from pink to blue, and clouds would form. Making the air breathable is the hardest part. Engineered microbes and plants could slowly convert CO2 to oxygen. Over centuries, hardy grasses and forests might take root. Terraforming is a project for generations, requiring patience and vision. It's the boldest engineering challenge humanity has ever imagined. The dream to walk on Mars under an open sky, unencumbered by spacesuits. It's a breathtaking vision of planetary gardening. We stand at a crossroads, Mars shimmering as both destination and dream. The journey is perilous, survival demanding technology and resilience. Colonists must build homes from alien soil, grow food, and extract air and water from a hostile world. The psychological and physical challenges are immense, yet the vision of terraforming, of breathing Martian air under a blue sky, remains a powerful lure. It's a legacy project, spanning generations. Whether Mars becomes a second home or remains a pristine wilderness, the dream inspires us. Our first duty: explore with care, searching for native life before we change the planet forever. Mars pushes us to be bolder, smarter, and more united. The red planet calls, urging us to reach for new horizons.